Good evening, Way Happy fans. This is Mr. Meyer coming at you from the Southside Studios here in Livermore, and we're about to get a little crazy. Sum and difference identities. Now we've taken a break from a couple identities, and now we're going to throw a bunch at you. So here they are. These are called the sum and difference identities because you're summing two angles together, and you're going to take the sine of, cosine, or tangent of them. So the first thing you want to understand is that sine of an angle plus an angle does not equal just sine A, sine B. It's not the distributive property. That doesn't work that way in trig. And so what happens is you actually have to memorize a formula. Now these are the meanest to memorize. As you can see, look at that. Sine A plus B, sine A cosine B plus cosine A sine B. Crazy. And look at the cosine formula of A plus B. It's cosine A cosine B minus sine A sine B. And down there you see the tangent one. It's tangent plus tangent over 1 minus tangent tangent. Well, funny enough, I got that lady who put jingles in my head, and she's kept them in my head there for a while now, so it's a little scary. But here's how it goes. Are you ready? You have to be ready to sing. So clear your throat and get ready. It's kind of a nice little catchy tune. So if we are going to do sine, we are going to sing sine, cosine, cosine, sine. There you go. That's it. Sine, cosine, cosine, sine. It'll get in your head. You'll be in the shower and you'll be like, sine, cosine, cosine, sine. It is great. And then you got cosine, which is cosine, cosine, sine, sine. That's it. Cosine, cosine, sine, sine. So let's put them together. Sine, cosine, cosine, sine. And then cosine, cosine, sine, sine. Piece of cake. And you know tangent's got something too, right? Tan, tan, 1 tan, tan. That's right. Tan, tan, 1 tan, tan. Oh, with those three little jingles, you will be able to memorize all of these formulas. So let's kind of set you up. Notice something about sine. If you're adding them together, you got sine, cosine, cosine, sine, right? You are also adding. If you are subtracting then, I'm going to jump down to this one, then you're going to have sine, cosine, minus cosine, sine. So same jingle, just notice the minus. So sine's kind of cool. Whatever symbol's in between the two, that's a symbol you bring along. Now look at cosine. Cosine kind of misleading, so you just got to notice something weird. Cosine adds here but subtracts here. So cosine, cosine, sine, sine. You just have to remember that you're going to change the sign though. Not S-I-N-E, but S-I-G-N. And so if I do cosine now, I'm going to have cosine, cosine, plus sine, sine. And there you go. And now look at tangent. We all know tangent is sine over cosine. And look at that. It copies on the top, just like sine does. And it does the opposite on the bottom, just like cosine does. So sine over cosine, kind of keeping its mojo there. And its song, tan, tan, 1 tan, tan. You got to love that, right? So you have tan A minus tan B, because it's going to copy all over 1 plus tan A, tan B. And there is your identities, or there are your identities. And 6 more that you get to add to. And you got that jingle, right? Sine, cosine, cosine, sine. Cosine, cosine, sine, sine. Tan, tan, 1 tan, tan. And just sing it in the halls. Enjoy it with your friends. Show your family. It's going to be a good time. I think they even made a song like that. It's going to be a good time. All right. We better do one of these. All right, let's give this a shot now. So you got your song, and you're looking at this first thing. The left side looks a little more complicated than the right side, so I'm going to go ahead and try that. I got cosine, so I know that that is cosine, cosine, sine, sine. Got it. So I'm going to write in here cosine of pi, cosine of theta, minus sine of pi, sine of theta. And that's supposed to equal negative cosine, so let's see. Now, not much I can do now here. However, wait a minute. I know cosine of pi, right? That's reference angle 0 degrees, fold down 0 degrees. That's 1. But it's over, pi's over and, in between quadrants 2 and 3. So that's negative 1 times the cosine of theta minus, now sine pi, I know that. Sine pi, that's, again, fold down 0 degrees. That's nothing over 2. So that's nothing. Well, then I guess it doesn't really matter because it's gone. And so that means we have negative cosine of theta. And hey, that's what we were trying to prove. 1 for 1 and feeling good. All right, let's try the next one. Now you kind of got the idea. So you're like, all right, I got to prove that sine pi over 2 minus theta, some unknown thing, has to equal cosine. So sine, cosine, cosine, sine, that's the song I need. So sine of pi over 2 cosine of theta minus cosine, cosine, cosine of pi over 2 sine of theta. And that's supposed to equal cosine somehow. Well, let's think. Sine of pi over 2, that's 90. That's a 90-degree reference angle. So fold down your thumb, and you're like, all right, if that's folded down, then I got to think sine is root 4 over 2. So sine is 1 times the cosine of theta. And cosine, that's the other side. That's 0 times sine. And that's just going to disappear. And lo and behold, we just have cosine theta, which is what we wanted. Check, check. Beautiful verifying, and I'm feeling pretty good. All right, let's see if you remember a song. Woo, high fives! Great job. All right, let's see if you still got this going for you now, right? So first thing you might notice is we're going to try to figure out what is going on here. And if you know the jingle, you got it. You're like, wait, sine, cosine, cosine, sine. Wait a minute. Sine, cosine, cosine, sine. I know what that is. That's just sine of two angles. So you recognize that. You jump up and down and you're like, that's just sine of 95. Let's see, plus, because it's sine 55. That's just the sine of 150. And lo and behold, wait a minute, I think I even know that thanks to my unit circle or my hand trick. So I can be like, that's a 30-degree reference angle. I'm going to fold down 30 degrees. Sine is going to be a half, but then I'm going to remember that that's over in quadrant 2 now. And so, hey, sine's positive in quadrant 2, and we're golden. So that's just another fancy way of saying a half. And we're done. All right, could you identify the next one? Cosine, cosine, sine, sine? That sounds like a song I know. Well, I'm learning. And so cosine, cosine, sine, sine, that is definitely cosine. Remember the trick? You got to change the sign though. So this is pi over 4 plus pi over 3. I don't know if I know that one. Let's get a common denominator real quick. So multiply this one by 3, multiply that one by 4, and I get cosine of 7 pi over 12. I don't know any over 12s. So that's as far as I can go. I can't evaluate it. I could only evaluate it if it was possible. Can't do it on this one. All right, last but not least, let's see what this last guy looks like. He's like tan, 1 tan. No, for crying out loud. It's one of each of them. A sine, a cosine, a tangent. It's following the tan, 1 tan rule. And so I know it's tan of 20. Is it plus or minus? Oh, that's right. Look at the top, right? It is plus 34. So now I know that this is tangent of 54 degrees. And I don't know 54 degrees. I know 45, but I don't know 54. So I'm good. See, it's helping. All right, how do you like this thing? Well, here's where it gets, all right? Somebody's going to ask you to find the exact value, or for some reason, we need the exact value of sine of 15 degrees. And we don't know it. We know 30, we know 45, we know 60, we know 0, we know everything but 15. And we're like, dang it. We need a calculator. Well, not anymore. We can get the exact value by using the formula. This is just two angles added together. Now the hard part, or subtracted, and you need to figure out what those two angles are. Little hint, if it ends in a 5, you should use a 45-degree angle. Hey, 45 and 30, if I subtract them, that would totally get me 15 degrees. And I know how to do that because I know the formula. Sine, cosine, cosine, sine. So sine 45, sine, cosine, minus cosine, sine. And I can tell you the exact thing because I'm going to use my hand now. Sine of 45, fold down 45, that's root 2 over 2. And thank goodness it's in quadrant 1. Cosine of 45 is root 2 over 2. So I did my 45s. Now I'll do my 30s, fold that down. Sine is the bottom, which is 1/2. And cosine is the top, which is root 3 over 2. And the next thing you know, you're done. Multiply those together. That's what, root 6 over 4. And that's root 2 over 4. Oh, I could kind of make that a little prettier. Root 6 minus root 2 all over 4. That's your exact value of sine of 15 degrees. And now you start to see, like, what? We can actually calculate sine of 15 exactly. We don't need the crummy calculator that just rounds it for us and, gives us an approximation. This is heaven. So anyway, you go ahead and you enjoy that as I try to do cosine of 165. So again, there's a 45 in there. I'm going to do cosine of 45 plus 120 because I know those two things add to 165. I happen to know 45 and 20. Make sure you know 120. Make sure you know things you know, right? Make sure you pick angles that we can actually do. So I got cosine of 45. Oh, what's the song? Cosine, cosine, sine, sine. Ah, nice. Cosine, cosine. And then remember it's the opposite. Sine, sine. And again, I'm just going to go ahead and grab 45, which I know is root 2 over 2 for both sine and cosine. Now 120 has a 60 degree reference angle. Fold that sucker down. Root 3 over 2 for sine. And 1/2 for cosine. Now I got to be a little careful because it's in quadrant 2. So let's see. That's where sine is positive, but that cosine was a negative value. No big deal. So now I got that. I'm just going to multiply this together. Negative root 2 over 4. What's that? Minus root 6 over 4. I can make that look a little prettier. Negative root 2 minus root 6 all over 4. And you're like, what? Insane. Right? Done. Now again, a lot of these are going to look the same because you're going to be using angles that are similar, 30s, 45s, 60s. So don't be surprised when you're like, wait, all my answers kind of look the same. They will. All right. What about 5 pi over 12? Holy smokes, where is that? Well, I know that this is 2 pi and I know this is pi. Now, if we want to talk twelfths, because that's the denominator, this is 12 twelfths. And this is 24 twelfths, so I guess it doesn't matter. Right between 0 and 12, though, would be 6 twelfths. Ah, so 5 twelfths is like right up here. Now, what two angles can I get that would add up to that? Well, that must be like a pi over 4 and something, right? That I'm going to have 12ths of. So really, let's, kind of multiply this by 3, and we'll have 3 twelfths. So how many more do we need? 2 twelfths. And so that to me is 1/6 or pi over 6. So this is really just sine of pi over 4 plus pi over 6. Nice. Well, sine, cosine, cosine, sine. Sine, cosine, cosine, sine. And I am ready to use my unit circle. Sine, root 2 over 2. Cosine, root 2 over 2. Now look, that's a 30-degree angle. Fold that down. Sine's going to be 1/2. Cosine's going to be root 3 over 2. We got a little subtraction going on in the middle. And I got root 6 over 4 minus root 2 over 4. Hey, lo and behold, root 6 minus root 2 all over 4. You got it. There it is, right? Sine. Now we have tangent. And tangent is a beast. But it's a good beast. So let's see. Tan, 1tan. Oh, first, what the heck two angles should we use? Well, I see negative 15, so let's go 30 minus 45. Sound good? Yeah, sounds great. High five. Yeah. All right. So now we got our formula. We're like tan, 1tan. So that is tangent of 30 minus tangent of 45. I know that one's 1. Sorry, that might have been creepy. And then 1 plus the tan of 30 and the tan of 45. And now I can just go ahead and start figuring out those. So again, hand trick. Folding down 30. Tangent is going to be 1 over root 3 minus tangent of 45 is 1 all over 1 plus tangent of 30 we said is 1 over root 3. And tangent of 45 is 1, so I guess it doesn't need to be there. Now you got some grossness, right? You're like, oh no. Yeah, that looks like a complex fraction where you got to get the top combined as to one fraction. So I'm going to give this guy a root 3 over root 3. So at least the top can be 1 minus root 3 all over root 3. Then you're going to do the bottom. And you're like, oh, the bottom needs a common denominator too. We got to give it a root 3 over root 3. And you're like, all right, so that would be root 3 plus 1 all over root 3. And then you're like, then I got to do copy dot flip, right? So 1 minus root 3 over root 3 times, flip it, root 3 over 1 plus root 3. And they cancel. And you're like, yeah, 1 minus root 3 over 1 plus root 3. Now, a little funny thing here. We could leave it, but I bet it cleans up pretty nicely. In fact, I really don't like my denominator looking like that. I would like my denominator to be a whole number. So that's the one thing I'm going to fix. So remember your conjugates, right? 1 minus root 3 and 1 minus root 3 on top and bottom. Now you're going to have to be a pretty good foiler. Let's see, the top. I'll do it kind of in steps here. So the 1, and then the minus root 3, and then the minus root 3, and then the plus a 3. And then the denominator, though, is going to be 1 minus a root 3 plus a root 3, and then minus a 3. Now I'm feeling pretty good. It looks like I have, what is that, 4 minus 2 roots of 3 all over 1 minus 3, was that negative 2? I can clean that up a little bit. I can factor out a 2 out of the top and have 2 times 2 minus root 3 all over negative 2. Those 2's can cancel. I can bring the negative up, and I can say, hey, tangent, your exact value is negative 2 plus root 3. Wee doggy! That was some fun. All right, folks. Stay happy. Remember your songs. Sine, cosine, cosine, sine. Cosine, cosine, sine, sine. Tan, tan, 1, tan, tan. And you will be just dynamite. Have a great day. Stay happy. And have a good weekend. What if it's not a weekend next time?